Is my screen visible? Anyone, please respond.
Yes, sir.
Okay. Right. Already we have completed introduction about thermodynamics in the previous class. We have studied what are the terms we can see in the thermodynamics, that is system, surroundings, right? Intensive properties, extensive properties, and all other things. Then coming to next topic, which is very, very important topic, you will get compulsory questions in some exam from all these topics, right? First one is that enthalpy. Already we have discussed about internal energy in previous class. Internal energy denoted with E, but here enthalpy represented with H. What is enthalpy first? Enthalpy is heat quantity of a system in constant pressure. Okay, what is enthalpy? It is a heat content or quantity. You say it is heat content of a system, right? At constant pressure. You say it is at constant pressure. Right? It is expressed with the equation H equals to E plus P, where H is now, it is enthalpy. E is what? Already we have discussed in earlier class, that is internal energy of system. PV is nothing but pressure volume. Are you getting my display? Is it visible? Anyone please respond?
Yes, sir.
Okay. So PV is what? Pressure volume. In thermodynamics, this pressure volume gives us a work. We will discuss later what is work, how can we get work, okay? What type of work we have seen in thermodynamics, right? So this is the main equation which represent enthalpy of a system. Okay. In other way, we can define the enthalpy. It is sum of internal energy and pressure volume of system. What I am doing here, I am defining the statement for enthalpy from the equation. Enthalpy is sum of these two, means internal energy and pressure volume of a system. This is another definition for enthalpy. Okay. Sometimes not only we can express like this, we can also express in for infinitesimal changes. For infinitesimal changes, it can be written as dH equals to dE plus PdV. Okay, this is another form of equation for the enthalpy. Or sometimes also we can write delta H equals to delta E plus P delta V. Okay. It is another expression for enthalpy. What is delta H? The difference between two enthalpies. That means delta H is called H2 minus H1. What is delta E? Delta E is equal to E2 minus E1. Okay. Initial internal energy of initial state and final stage. Enthalpy of products and reactants. The difference between two enthalpies, that is products and reactant, that gives delta H value. Okay. When we subtract the internal energies of two states, means initial stage and final stage, we will get the delta E value. Then what is delta V? V2 minus V1 means initial value, final value minus initial value. V is your value, right? All these are the equations we can see in the thermodynamics for enthalpy. Okay. It is very, very important you remember all the equations and the definition. Is it clear?
Yes, sir.
Right.
Yes, sir.
Okay. Coming to work. It is represented with W. Okay. Work can be given by formula. Physical. In physics, we can see work equals to force into distance. The product of these two, force and distance, gives us work. It is a physical term. Force is represented with F, the distance is L, work is W. This is the formula for work. Right? The units of work is nothing but energy. Units can be applied here. Units of work ergs, right, or joules, or calories, or degrees. We use all these units wherever they are applicable. Right. This is general formula for work. For our thermodynamic, in our thermodynamics, work came from the pressure volume. Work done by the pressure volume changes. So that gives us mechanical work, which is called pressure volume work. Pressure volume work. It gives us a mechanical work. Okay. So in a change of volume of any system, then we will get some work. That work can be done by the system or can be done by the surroundings. Okay, that's why we can express in both the way. Work done by the system. Work done by the system with pressure volume. I'm taking only volume. Volume increase. Volume increase. Volume increase means what happens? Expansion takes place. Increase in volume, that gives expansion in the system. Okay, it is expressed with W is equal to minus P delta V. Okay, work done by the system can be expressed with this formula. You remember this formula, which is very, very important. Work comes from pressure volume. If there is a change in volume, that gives us a work. Okay. If work done by the system when volume is increases or expansion takes place. This is the first case. Coming to second case, which is work done on the system. Work done by the system on surroundings, work done on the system by surroundings. Okay, with volume decrease. Volume decrease. Decrease in volume means what? It is compression. It is compression. Okay. So it can be expressed like this. W is equal to P delta V. Here no negative sign. Okay, you observe this. Both the formulas. Here we are getting negative. Here not getting negative. That is the difference. Okay, it is positive. W is equal to P delta V, which gives us work when in a system there is a decrease in value. Okay, this is about what? Work, what we can get in the system. Work done by the system, work done on the system. These two things we can see in thermodynamics. Okay. Shall I go further? Any doubt? Are you there?
Yes, sir.
Okay. Is it clear now?
Yes, sir.
Okay. Now, coming to very, very important thing is first law of thermodynamics, which is very, very important. First law of thermodynamics. What it says, that is important. Okay. There are several definitions to explain first law of thermodynamics. The first one is energy can neither be created nor be destroyed. In any system, we cannot create energy or we cannot destroy energy. Means if a system has some energy, we cannot increase the energy of that system. We cannot decrease the energy of the system. That it means. What will happen then? It can be transformed from one form to other form. That's all. There is no disappearance. There is no new energy created. But it can be transformed from one form to other form or another form. This is the first definition of first law of thermodynamics, which is very, very important. Okay. it gives us law of conservation energy. Okay, the statement shows that what? Law of conservation of energy. Energy can neither be created nor be destroyed. Okay, coming to second definition, which is when it is similar to first one, but it is expressed in different way. When one form energy, one form of energy disappears exactly same amount of energy, same amount, you see, same amount of energy appears in some other form. Okay. Total disappearance is not possible according to law of conservation of energy. Right? When one form of energy disappears in the system, exactly same amount of energy appears in some other form. This is the second definition. Right? Coming to third definition, which is very, very important. All are important, but mathematically we can express first law of thermodynamics by using this. Suppose if you consider a system is gaining energy. How does system gains energy? By heating system. Okay. When heat is absorbed by the system, what will happen in the system? That is important. Right? The absorbed heat by the system, some of the energy, heat energy, used to increase in internal energy, and remaining heat used to do work either by the system, okay, or by the surroundings. But I can stating here, when the system absorbs energy, heat energy, some of the energy, heat, used to increase in internal energy of the system, and remaining energy is converted into work. Okay, work which is done by the system. That means the absorbing heat is always represented with Q in thermodynamics. The heat absorbed by the system Q is equals to the change in internal energy. What is internal energy? Already we have studied. E is internal energy. Change can be expressed with delta value. Okay. Every system has its own internal energy. Already we have discussed in earlier class. The energy comes from different modes of vibrations and translational and kinetic and potential. Some of all these energies are called what? Internal energy of the system, right? When heat is absorbed by the system, some of the heat used to increase in internal energy, means internal energy changes from E1 to E2. The difference E2 minus E1 gives us what? Delta E. Delta E means what? Change in internal energy. Wherever you see delta, that gives what? change from one stage to other stage, delta E, right? So energy, internal energy increased. Some of the heat used to increase in internal energy and remaining energy used to work done by the system. This is very, very important expression of first law of thermodynamics. First law of thermodynamics. Q equals to delta E plus W. Coming to statement, what we can write? Statement. Heat, that is Q. Sorry. Absorbed by the system is the sum of these two, sum of increase in internal energy and this term is over. Internal energy and what we can say? The W is work done by the system. What is W? Work done by the system. This is a very, very important statement for first law of thermodynamics. Okay, all these are the definitions for first law of thermodynamics. First one is what? Energy can neither be created nor be destroyed. It can be transformed from one form to other form. When one form of energy disappears, exactly same amount of energy appears in some other form. This is second definition. Coming to third, heat observed by the system is the sum of increase in internal energy and work done by the system. That is Q equals to delta E plus W, which is mathematically expressed first law of thermodynamics. Okay. Similar to enthalpy, this expression can be expressed in different way. Q equals to delta E plus W. This is one type of expression. Or if you are taking infinitesimal changes means there is a small change in heat. There is a small change in E. There is a very, very small change in work. Then we can say infinitesimal change. Okay. To apply in infinitesimal changes, we can write the equation in other form. That is dq equals to dE plus dW. All these equations you must remember. Okay, this is the other form of expression. Sometimes it can be expressed like this: dq or dou q, dou E. In some books we can see like this. Okay, you use any form, any expression. You can give any expression in the whenever you write the statement of first law of thermodynamics. You use any one. Okay, right. Now, coming to next one. Already we have seen that work done by the system is the work of expansion where volume is increased by delta V with external pressure P. When we apply external pressure P, there is a change in volume that gives us some work in the system. Okay, already we can see that in a earlier slide, that is W is equal to PdV. PdV. Okay. When we
Sir, sir.
it is not visible to you. Okay, then right.
Yes, sir.
Okay. W is equal to PdV. Already we have seen the change in volume gives us work, right? At by using external pressure. When we use this, Q equals to delta E plus what is W? PdV. Okay, what is our equation? Q equals to delta E plus W, right? When we replace W value in this equation, then we will get this PdV. Yes or no? Why? Because W is equals to, sorry. W is equals to PdV, right? Or we can write dq equals to dE plus PdV. It is another expression. All these give same quantity. The expression is different, that's all. Okay. Or also we can write Q equals to delta E plus, for dV, we can also write P delta V. It is another expression. However you express, okay, that is correct. Either you express by this equation or by this equation or this is okay. By any way, it is correct. Right. Coming to the application of first law of thermodynamics at different conditions. The first condition is at constant volume. What will happen? At constant value. Constant volume means what? There is no change in volume, means delta V equals to 0. Yes or no? At constant volume is not changing. Volume is not changing means the delta V, difference in volume is 0. Difference in volume is 0. Delta V is equal to 0. Then what becomes first equation? Sorry. Q equals to delta E plus P delta V, right? Then Q equals to delta E plus P into delta V. Well, what is the value of delta V? It is 0. Delta V value is 0 now. That's why I'm taking here 0. Then what we will get? Q equals to this total becomes 0. Then only we can have delta E. Okay. This is expressed Q with QV. QV. Okay. What does it says? At constant value, when the system is absorbed some heat, the total heat of the heat absorbed by the system, the total heat is used to increase in the internal energy, right? But what it gives us, when system absorb heat Q at constant volume, V means at constant volume, is used to increase in internal energy only. We cannot see any work at constant value. Are you getting my point? Anyone? Are you getting my point? Hello? Are you
Sir.
there? Ah. Okay. Did you understand? QV equals to delta E. What? Q is heat observed by the system at constant value. Is only used to increase in internal energy, but not work. Okay. This is first case. Coming to second case, at constant pressure. At constant pressure, what we can see, QP equals to delta E plus P delta V. P is constant. If it is some value, this will be change. If it has same value, some value, it will be change. At constant pressure, there is a change in value. That's why at constant pressure, we can write the equation is QP equals to delta E plus P delta V as it is. That means at constant pressure, the amount of heat absorbed by the system is used to increase in internal energy and some of the heat used to work done by the system. Similar to first law of thermodynamics. Only it changes at constant value. At constant value, the energy absorbed by the system used to increase in internal energy only. That is not used to work done by the system. Okay. So these are the expressions of first law of thermodynamics. You remember all those things. Okay. What we have seen, Q equals to delta E plus W. This is the first one. Second one is what? dQ equals to dE plus dW. Okay. Third one is what? Q equals to delta E plus P dV. Okay. Fourth one is what? dQ equals to dE plus PdV. Okay. Fifth one is what? Q equals to delta E plus P delta V. Okay. All these are expressions for the first law of thermodynamics. Okay. You use any equation, that is correct. Okay. Whatever you write among all these five, that is correct expression of first law of thermodynamics. Is it clear?
Yes, sir.
Okay.
Sir.
Is it clear?
Yes, sir.
Yes. Okay. It is very, very important thing. You read again and again, practice all these equations, you will get clear idea about it. Shall I go further? We have less than 1 minute. Okay. I wanted to cover more topics today. In Zoom, there is a problem. Only 40 minutes we have. We will disconnect within a minute. Okay. But in case of Teachment tab, we have no time limit. In Google Meet also we have. Tell me. Someone.
Afternoon తీసుకోండి class.
After physical or online?
Online.
Online. At what time?
మీ ఇష్టం సార్.
అంతేనా? డన్. ఓకే.